Mass balance equation and charge balance equation are one of the two steps in writing the systematic treatment of equilibrium. So here in the video, we will just focus on the charge balance equation for us to understand its basic concept. So the electrolyte solution are electrically neutral even though they may contain several moles per liters of a charged ion. The solutions are neutral because the molar concentration of a positive charge in an electrolyte solution are always equal to the molar concentration of a negative charge in an electrolyte solution. So here, the number of moles per liter in a positive charge is equals to the number of moles per liter in the negative charge. So this equation represents the charge balance condition and is called the charge balance equation. So we should remember that the charge balance equation is the sum of the positive charges equals to the sum of the negative charges in solution. So here is a simple equation to follow in writing the charge balance equation. The N here represents the cation charge, the C represents the cation concentration, the M represents the anion charge, and the A represents the anion concentration. So this part is the positive and this one is the negative. For our first example, if we have a sodium chloride and we have it in water, we will have a sodium ion present and a chloride ion present. So the Na plus the Cl minus. And then since it is in the water, we also need to take into account the auto-ionization of the water. So 2H20. And we also have the hydronium and the OH. So these two are present due to the dissociation of water. So here in the charge balance equation, we just need to write all the positive ions on the right side, which is the sodium and hydronium, and on the left side is the negative ion, which is the chloride and the hydroxide. So this is just a basic example in writing a charge balance equation. For our second example, if we add something like magnesium that has a 2 plus charge, then the balance equation changes a little bit. So now we have to include the coefficient of the charge. So the coefficient here is 2 that matches the charge. So our charge species are in the hydronium ion of the magnesium, and then the chloride ion is on the hydroxide ion in a solution. So again, we should always remember that the coefficient are matched with the charge. The example here is 2. For our last example, consider the analytical concentration of magnesium chloride with 0.100 molar concentration. So in the first equation, the molar concentration of magnesium ion is multiplied by 2. So 2 times 0.100 because 1 mole of that ion contributes 2 mole of positive charge to the solution. Then in the second equation, the concentration is twice to the magnesium chloride solution. So 2 times 0.100 plus OH. So the 2 is from the charge of the magnesium chloride. And then to get the charge balance, we just need to equate the equation. For neutral solution like this, the hydronium and the hydroxide are very small. Remember the equilibrium concentration, which is 1 times 10 to the negative 7 molarity. Then here we can simplify the charge balance equation. So this is the final answer.